I got the notes for solving exponential equations with logarithms. So if an equation is only exponential on one side, so maybe something like 4 equals 2 to the x, or it's difficult to find a common base or you just don't want to, a logarithm can be used to solve the equation. So the power property of logarithms allows the exponent to its coefficients. We'll talk about the other properties of logs in the next lesson, but this is the one that's important for today. When you use a logarithm, which is an operation like a square root, it allows you to pull any exponents out front. When taking logarithm, use a common logarithm, which is log, or the natural logarithm, as these are able to be evaluated on a calculator. I prefer to use the natural log, the ln, so that's what we'll be doing here. So the logarithm in general is the opposite operation. So like addition and subtraction are opposites, multiplication, division, squares and square roots. The logarithm is the opposite operation of an exponential. So when we're solving, our general steps are to get the thing that has the exponent by itself first. So for this one, we'd have to divide both sides by 50. I would recommend you probably stay in fractions. You don't necessarily have to simplify your fractions, but I'll leave it as a fraction. So now that we have the thing that has the exponent by itself, and we're going to do a logarithm on both sides. So I prefer ln. If you prefer log, it doesn't actually matter. You'll get slightly different values in the middle of the problem, but at the end, you'll get the same thing. The reason we do that is it lets us pull our exponent out front. So this would be our equation. So now you could evaluate what ln 9 over 50 and ln 3 are right now, determine the decimals, but it's actually easier if you divide this across and do the calculator step all at once. So what I do is I come to my calculator, see if I can get it to show up on the screen, kind of. So ln of 9 over 50, remember the fraction bar is just division, divided by ln, whoops, too many divisions, ln 3, so negative 1.561. We know a value. So now, even though we have a decimal, it's just a one step here, so divide both sides by 3. Round to the nearest hundredth, so negative 0.52 would be my solution. On these intermediate steps where you have the decimals, you probably want to carry at least 3, if not 4 decimal places, just to make sure you have enough to round correctly at the end. Okay, so for number 2, we need to get that by itself. So divide both sides by 12. Okay, so now the thing that has the exponents by itself, so we're going to ln both sides, which lets us pull our exponent out front. This. So then we're going to divide both sides by the log that's on the same side as the x to move it across. So we'll have x over 2 is equal to, that's a calculator problem. So ln 1/12 divided by ln 10. So negative 1.0791, technically 2. Now then to get rid of the x over 2, we would multiply both sides by 2. So x equals negative 2.16 if I round. Also as a note, I'm writing the decimals here, but I'm not clearing them out of my calculator. So I'm instead of retyping my decimal, I'm just hitting ×2 and just doing the whole thing without being rounded, which also helps keep you from doing rounding errors. All right, so number 3. So we got to get that guy by itself. Divide both sides by 65. So 2 to the 2x equals 455 over 65. So just as a note, like that definitely reduces. They both end in 5, but it's not part of my final answer, so I'm just going to leave it alone. So ln on both sides lets me pull the exponent out front. So 2x times ln 2 equals ln 455 over 65. Divide the log term across. So that would give us 2x equals ln of 455 over 65 divided by ln 2. So that gives me 2.807. And then to get x by itself, divide both sides by 2. 1.40 be my solution. So this one's just structured a little bit differently. Instead of the multiplication dot, we have just the parentheses, but it's the same first step. We got to get the thing that has the exponent by itself. So divide both sides by 1,000. So 10 over 1,000. Now, once the multiplication is done, I don't need those parentheses anymore. So I would have that. So ln, lets me pull the exponent out front. So ln 10 over 1,000 equals x over 14 times ln 0.5. So I'm kind of moving everybody to the left this time because my equation is backwards from the previous ones. All right, so we'll have ln of 10 over 1,000 divided by ln of 0.5. So that gives me x, well, 6.644 equals x over 14. So everybody multiplied by 14. So x equals 93.01 as my solution. Okay, so 5 does add actually one extra step, and that's that 62. So my goal is still to get that by itself. So this acts like a 2-step for now. I need to get rid of any multiplication or addition and subtraction, but addition and subtraction have to get moved first. So this equation, I add the 62 across, now looks like all the ones we're doing, so divide everybody by 9. So 73 over 9 equals 5 to 3x. Once again, once that 9's gone, I don't need the parentheses. ln on both sides lets me pull the exponent out front. ln 73 over 9 equals 3x times ln 5. Get rid of the ln 5 on both sides. So we'll have ln 73 over 9 divided by ln 5 gives me 1.301 equals 3x. So divide both sides by 3. 0.43. All right, last one. So divide by the 520. So 23 over 520. 0.5 to the x over 7. I left the parentheses even though I don't need them. ln on both sides lets me pull the exponent out front. So ln 23 over 520 equals x over 7 times ln 0.5. Divide this guy across. Gives us 23 over 520 divided by ln 0.5. 4.499 equals x over 7. So multiply both sides by 7. 31.49. And that brings us to the end of the section.